Everyone, today we'll be discussing questions from differentiating trigonometric functions, a key concept in calculus that you'll definitely need for your exams. On the left-hand side here, I've actually written down the rules that you need to remember, but let's go through them real quickly. When you differentiate tangent, you're supposed to get secant square as well as the differentiated value inside here to multiply to the front. Same concept over here. When you differentiate sine, you will get cos, but you also need to differentiate what's inside the bracket and multiply it to the front. And lastly, when you differentiate cos, you would actually get a negative sign. Okay? Negative sign multiplied with the differentiation inside the bracket. So let's look at the questions that we have here today. For your first question, differentiate y equals to tangent x minus square root of x with respect to x. In this first question here, first of all, like I mentioned, tangent will turn into secant square. Then when you differentiate trigonometric functions, whatever is inside the bracket will be just the same. You just repeat and write it back down. Now, for whatever is inside the bracket, we need to differentiate them first. Differentiate x, you will get 1. Differentiate square root of x, you would have gotten 1 over 2 x to the power of negative half. Rewriting this whole equation, you would have gotten 1 minus 1 over 2. Bring the negative indices to the denominator, will become power of 1 over 2, back to square root x, secant square, bracket this, and bracket x minus square root of x. Okay? Looking at your next example over here, differentiate y equals to tangent x plus 4 minus 3 sine x. So in this question, we have two trigonometric functions, tangent and sine. Differentiating for tangent, you would have gotten secant square. Again, repeat whatever is inside the bracket. Then differentiate what's inside the bracket is just 1, so we will not write down the number there. Minus 3 sine x. So differentiating sine, okay? The way that I used to remember it is differentiate sine gives you cos, sounds like design cos. Okay? So when I remember design cos, I would have gotten this to become negative 3 cos x. Okay? Next. Differentiate y equals to x sine 4x with respect to x. To do this, you must remember to do your product rule. So your product rule states that, first of all, you must differentiate this value here, x on the left-hand side, to give you 1. And then you're going to copy down whatever is on the right-hand side, sine 4x, plus differentiate the right-hand side here. Differentiating sine, you're supposed to get cos 4x. Then differentiate the 4x here, you get 4. And remember to copy back whatever was on the left-hand side times x over here. Now, when you rewrite this equation, dy dx, first of all, this is just going to be sine 4x. Over here, this is where the students usually make their mistake, is that they would sometimes write this as 4 cos 4x square. This is actually wrong because the x does not multiply into the cos function. Instead, the x multiplies to the numerical number in front. So it's 4x cos 4x. Okay? Make sure to not make this mistake over here. Next question. Differentiate y is equals to 3 sine 2x with respect to x. Once again, design cos. Differentiate sine gives you cos. Cos 2x, right? The 3 is still in front, then multiplies with the differentiation of 2x. So times 2 here. Therefore, you would have gotten 6 cos 2x. DYDX is equals to 6 cos 2x. Just write it nicely, okay? Okay, next question. Differentiate y equals to 4x minus 4 cos 2x plus 4 with respects to x. So differentiating for 4x, you would have gotten 4. Differentiate for cos 2x. This will become sine 2x, and then 4 remains in front. But when you differentiate cos, it turns into a negative, right? So you have minus negative 2 times 4 sine 2x. Differentiate 4, you get nothing. So therefore, dy dx is equals to 4 plus 8 sine 2x. Okay? Next question. Differentiate y is equals to 4 cos 3x minus 4. Once again, differentiating cos, you will get negative sine. So sine 3x, differentiate 3, you get negative 3, like I mentioned, because of the differentiate cos to become negative sine. Minus 4 becomes nothing again. This equation, dy dx is equals to negative 12 sine 3x. Okay, next question here. Differentiate y equals to 10 sine 2x minus 6 cos 2x. So this one, you have to differentiate both sine and cos. Once again, differentiate sine, you will get cos 2x. The multiplier in front is times 2, right? Minus differentiate cos, you will get negative sine. So sine 2x times negative 2 times 6. Rewriting this whole equation, dy dx is equals to 20 cos 2x plus 12 sine 2x. Okay. And one last question over here. Differentiate y is equals to tangent 3x plus 1 with respects to x. So a quick reminder is differentiating tangent gives you secant square. Then repeat whatever's inside the bracket plus 1 and differentiate it, you get 3 in front. Therefore, dy dx is just equals to 3 secant square 3x plus 1.